Hi everyone, my name is Chinenye Okafor. It's my pleasure to be here at Sigstore to be giving this talk on trends and ecosystem dynamics in Sigstore. A little introduction about me. I'm a PhD student at Purdue University and I'm part of the Trustworthy Software Ecosystems Lab. What we do in my lab is that we try to build an understanding of the different software supply chain and try to improve the security posture. And some of the projects that we've been working on is Sigstore, Intoto, Guac, and some other ones. We try to build open source tools that enables software producers and consumers create and consume software securely. So in today's talk, I'll be discussing the need why we need to be monitoring Rekor log to strengthen supply chain security. Well, before I go into details, we first of all try to go over Sigstore overview. Sigstore is a solution that enables secure software signing, it provides transparency, and enhances accountability. When I say secure software signing, I mean that it allows software signers to not worry about key management. Instead, they just use the identity, they just verify the identity, and they sign software and deliver it to whoever that wants to verify the software. When I talk about transparency, I'm talking about everything that is signed, it's accessible by anyone. Anybody can verify that it's correct. Anybody can verify that who signed it, what was signed, and other things. By accountability, these first 2 points enables us verifiers to hold software producers accountable, and it equally raises bar for different classes of attacks that have been happening in the past 10 years. So for those that are not familiar with Sigstore, the way Sigstore works is that you get the client library, which is cosign, and it generates a signing key for you. But before it does that, it needs to verify your identity. So it redirects it to identity provider where you verify that you are who you are, that's using your email address. And then the result of the authentication produces an authentication token, which is sent in addition to the generated key to a certificate authority, which is full store in the case of Sigstore. So the certificate authority will bind the generated key to the received identity token in a certificate. And with the certificate, cosign is able to sign the software, and the resulting signature is uploaded to a Rekor transparency log. I'll come back to this Rekor transparency log in a minute. If we look at this, could we guess anything that is missing? That's right, monitoring. Like I said earlier at the beginning of the talk, I'll be telling us why we need to monitor the log and things that could happen if we are not monitoring the log. But right now, I monitor the Rekor log, so you didn't have to. And I will tell you what is in there, whether it's good or whether it's bad, or whether we should be worried, or whether we should develop more tools to monitor the log. So basically what I did is that I did a Rekor archaeology. Think of this as trying to learn about a software supply chain by looking at Rekor log and trying to understand the different security and practices of software delivery. So specifically, I collected signed signature from the inception of Sigstore to the August the 6th, which was approximately 120 million entries. And then I passed it to get some interesting metrics that I was interested in: who signed these signatures, what are the timestamps, the signature types, and get all the certificate information I could glean from them. So one of what we what we're able to like find from what we collected, the first one is having this graph. Like this shows that since inception, Sigstore has seen a massive increase. And looking at this, can anyone, looking at this, there seems to be some uptake in so many places. Can anyone, like looking at this one that happened, that seems to be around the October of 2022, can anyone guess what happened around that period, or if there's like any major event that could have, caused a spike in Sigstore usage? Exactly, that was when Sigstore, that was when Sigstore was announced to be generally available. And so the spike could be, or I would believe that is a consequence of this GA. Again, if you look, we'll see like some other spikes in some other places. And the reason is, the reason I believe could be a consequence of GitHub supporting artifact attestation for NPM, like the public beta that happened, and it's caused this uptake here. Another major event that happened was the GA for GitHub artifact attestation. So, but again, when we look at this log, we'll see that a lot of people are using Sigstore, right? This paints that users, organizations, or whoever is using Sigstore, they are just using Sigstore. Well, the question we are asking is this usage based on certain set of people, or we are having like new set of organizations adopting Sigstore like on a daily, monthly, yearly basis? So to be able to find out this, we try to collect the different identities down Rekor, then try to extract the repos, the GitHub repositories, and we try to categorize them, whether they are of type organization or user type. And we have this. So like me looking at it, we could see a general trend, increasing growth with few dips here and there. One of the uptakes is this one around the April of 2023. From the previous slide, we could remember that this is when GitHub artifact attestation public beta was announced. So I would believe that this is direct consequence of this, because a lot of people now started using Sigstore, new organizations started joining. And again, we have another uptake around here, which is again when it became generally available. So I got this picture from, this image from OpenSSF landscape for Sigstore project. So basically it shows the different companies that are signing software with Sigstore, the different integrations that there are, and looking at this, having this and looking at Rekor, it's obvious that this doesn't even scratch the surface of the number of organizations that are in Rekor and actively using Rekor. So we found that less than 1% of organizations in Rekor are on the landscape, and the remaining 99 are not publicized. Like, we are now aware whether they are using Sigstore or not. That's not to say that they have to, but that's like a highlight to show that people are using Sigstore and the log really cut steep. So now I will stop here to take a break from trends and adoptions. So far I've been talking about like numbers, who are those that have been using Sigstore, like what are the new organizations that are joining. But monitoring is way more than that. As much as we have like more usage, it's equally it to having more entries to verify, right? And monitoring helps us to provide security and trust in the log. But for now, I'll try to get the technical terms out of the way, so we'll focus on monitoring as a crucial element in ensuring software supply chain security. So I talked about Rekor before. We may be familiar with Rekor. Like I said before, it is where we sort of dump signatures when we generate them until a verifier sometimes needs to verify a software, then it goes back to Rekor to find them. So Rekor is a tamper-proof log that tracks all signing activities, who signed it, when it was signed, what was signed, and some other information when it was included in the log and stuff. Secondly, it's publicly accessible for verification, meaning that anybody can verify it. And it provides a means to hold authorities accountable, meaning that if somebody signs something that is not supposed to sign, who will notice and who will find you? And lastly, but not least, the log by itself does not provide enough security guarantees. Yes, it provides a global view about the state chains, but then on its own, like without being monitored, it does not really provide the guarantees that it's supposed to. Not to say that it's not useful, rather that we say that it provides a means to verify the cryptographic information that we use to verify the signed signatures. So now, how then do we monitor this log to make sure that it's behaving the right way and the correct signers are signing the right things? The way we do it is through monitoring. You may have heard of witnessing and monitoring. They are two separate things, but then they usually work hand in hand to hold different stakeholders accountable. So witnessing mostly focuses on the global consistency of the data structure. It makes sure that history has not been rewritten, that everybody is having the same view of the log. On the other hand, monitoring tries to verify that the individual entries in the log conforms to a particular correct semantic. So it's local to the claims of the different authorities. Again, this means that witnessing works as long as the data structure is the same. That means it's a one-size-fits-all. On the other hand, monitoring needs to be aware of the information in the log to be able to, compare it against some ground truth. So we may be thinking either of these, which is more important? Is witnessing better than monitoring? Can we do with one and be okay without the other? But the truth is, both of them, they are both complementary in the sense that they hold different stakeholders accountable at different times. Witnessing verifies the log to make sure that the state chains are consistent, so it holds the log accountable. On the other hand, monitoring holds the other stakeholders accountable. For instance, how do you know if somebody is signing a malicious software using your identity? It's monitoring that you have to use. Witnessing could, pass or check that it's consistent, but then there is something wrong with the log. For example, some security relevant monitoring checks are timestamps incremental? If they are not, then there is a problem with the log. Are certificate mapped to identity issuer pair? Does signing happen within the certificate validity window? To put differently, the question is who is monitoring what and when is this signing activities? Who is signing what and when is this signing activities happening? So you may be asking, why do I want to do this? But the answer is that you really have to do it. You really have to verify it to make sure that people are not misusing Sigstore and abusing the security guarantees that it provides. Because really, if you provide a facility that enables signers to sign their software, those signers can equally use this facility to sign malicious software. So an instance is this famous case where large piece of malware used authentic code certificate to sign the malicious package, of course, which avoided it, like prevented it from being flagged when it's installed on different workstations. So to investigate, like to even think about how do we prevent misusing Sigstore, the first thing that I thought of is like what are the types of identities that are even signing in Sigstore? Like what do they tell us about maybe how to improve the security? So going back again to the log, we try to categorize the different signing identities, right, to majorly 3 categories. The first one is the human accounts, anything at Gmail, at Microsoft, at Outlook, whatever. Then the machine identity is identities signing that happened using service accounts or GitHub workflow or GitLab. Then we have the key signing where different people don't choose not to do keyless, but then they provide their own keys. So we found that the most signing actually uses machine account, then followed by key signing, and we have very little. It's not entirely 0%, but it's so little that when you compare it with the rest of the other categories, the human identity that are signing almost amounts to 0. So drilling down to the machine account, we found that most signing activities were done with mostly GitHub Actions, right? Because, I mean, from the previous slide, we saw like the huge spark of adoption by different organizations. So going down to some of the findings that we did. So you may be wondering if other certificate authorities are providing keyless signing, and the answer is yes. Fusio, although Fusio is providing like the major number, we have like 99.7 of certificates issued by Sigstore, by Fusio, and then the remaining 0.3% certificates were issued by other authorities. Some of these certificate authorities were DigiCert, some self-signed test certificates, and some other CA. And for the different CAs, their validity ranges from minutes to months to years. So for inclusion proof, for timestamp of entries, like when they were integrated into the log, we found that 566 signatures were integrated outside the Fusio validity window. That doesn't mean that they are malicious or anything is wrong, but then it kind of highlights the need for us to be verifying signatures using the timestamping authority, for the actual signing time. Because as the log grows, it probably happened that the integration time equally increases. So for the other CA, we equally found some entries that were outside the certificate validity window. But interestingly, we found 8 entries that were integrated into Rekor log even before the certificate validity. So I'm wondering, how did the signing happen for Rekor to accept this signing metadata? Because it means that the certificate is in the future, but then it has been logged. So was it signed with a certificate that was in the future? So I've listed some of the entries in case you want to, take a look. They really look interesting. So some other findings, we found that Fusio so far has been issuing ephemeral certificate of 10 minutes, apart from one instance. And this one instance is actually very silly because the increment is just by 1 second, which makes me wonder, is it inconsistency in terms of the full seal clock, or is it something else? Going back to this, monitoring Sigstore logs is important because it allows us to detect different things. It allows us to know when there is any malicious activity, if clients are, signing additional artifacts to what you want them to sign, if somebody else is compromising your identity and using them for signing, if the log is honest and true. And then it helps us, in case issues come up, it helps us to identify these issues on time and implement some timely incident response. Again, it's not a matter of what did we find in the log today. It's a matter of when we want to check the log, like, are we going to be able to answer the question of whether there is a malicious entry in the log, and what can we do about it if there is something wrong? So this is why I think we need better monitoring tools for Sigstore. The second thing is, what do we do if we find something malicious? How do we communicate this to users? How do we communicate this to stakeholders? So right now, we are doing research that we are trying to find how to do this better. And some of the things we are trying to do is to look at the witnessing literatures and try to find if we can find some solutions from that aspect. So far we have different papers with different protocol proposal and architecture, and each of them have different performance, different trade-offs, and different trust assumption to ensure witnessing. But then what if the solution is not in witnessing? Maybe we need something else, something that is not a one-size-fits-all. Maybe we need something that better understands the correct semantics of the Sigstore ecosystem and uses that to detect issues. So other things to think about is, how do we provide stronger security guarantees, especially considering the different identity types that are involved in signing? So some of the things we are thinking is, should we have some sort of multi-factor authentication or a multi-vantage point identity verification, just like Let's Encrypt, to ensure that a single compromise of an identity does not enable malware to be signed and introduced to the supply chain. Then, as I said earlier, we need to provide actionable monitoring. How do we quickly and effectively communicate with stakeholders or users if something is wrong in the log, so they'll be able to take action? This is to say that we want to limit the use of maliciously signed software in the future. That is how do we devise new mechanisms that will enable us prevent Sigstore misuse? So we are trying to start somewhere. We are trying to understand how the system and the where the system and the ecosystem is currently sitting, and what are the concerns that we have. Some of the things we are trying to do is to understand how people are using Sigstore to secure their supply chain in terms of signing or the verification aspect. Then we want to understand how people understand how signers understand monitoring. And finally, what are the challenges that signers are currently facing with monitoring, if any? So for this, we've developed a very quick survey that has been approved by Purdue Institutional Board. And it only takes 5 to 7 minutes. It basically asks you questions about how do you use Sigstore, how do you monitor the record entries, and what are the issues that you found, what are the challenges you're having, and things like that. It's completely anonymous. The information that you're providing does not map to your identity in any way. And the responses that you provide will help us perform fundamental research on how to improve monitoring practices and tools. So I invite everyone to please take the survey and help us improve monitoring. And that is all from me. I'm happy to take questions.
What was the most surprising thing that popped out to you in the data as you were doing this work?
The surprising thing is, so part of the things we try to do, we tried as much as possible to find something wrong. So we tried to find the log lagging. And again, we tried to find if we can find some malicious artifact that have been signed in the log. So not being able to find this is actually surprising to me. And I still believe that if I look harder, I might still find. So for now, that's the most surprising. So it means that, we are doing good, but we need to do better with monitoring.
Is there metadata that you think would be useful for a monitoring service to have exposed, as long as it's privacy conscious? Like was there a piece of data that you wish you had on a signing record?
I'm trying to understand the question. I mean, not really, because the log, everything is in the log, so anything we needed was there. So, again, there are some entries that obviously we are not signed by Fusio public instance, but then I find like some issues with the logged metadata on Rekor. So if I had access to them, I could have maybe found out like, why do we have this? Or could this be test cases? Why are people actually testing these? Are we trying to find a way around Sigstore security and things like that?
I guess the only thing that I can think of is, obviously if somebody's signing on their laptop, then we don't want to be recording their public IP, but if it's a company where you specify in a policy, every time we publish this software, it publishes from this runner that's on this, has this metadata or has this policy, then you would be expecting it to come from there. And then it would be unusual if the builder signed something that was built on a MacBook instead of on a Windows machine or something, or yeah.
Yeah, so for something like this, there could be, but I can't really tell because I wasn't the one that set the policy. Like, I can't really tell what it's supposed to build from. So it's not the responsibility of the signer to monitor it against what you expect it to be to know when it's misbehaving. So in this case, I can't really tell what is right from what is wrong, or what is wrong from what is right.
Sorry, I wanted to make a quick comment and maybe a question. So the comment around this is, I think we could certainly train an IDS or an IPS based on the metadata that we're consuming to see if anything kind of falls out of hand. Do you think that from attestations, what would be your favorite or your preferred method to actually train something like this to detect anomalous behavior? Do you think with the infrastructure that you built, you could actually build something like an intrusion detection system for Sigstore?
I think we can to an extent. There are certain things that are constant, right? Regardless of what the signer knows and what I don't know. Something like signing needs to happen within a bound, right? For something like that, I can use the attestations to build a system that detects this. A situation whereby we have multiple signing using the same certificate, that is something I can detect. Another situation where, I feel like there are just a couple of things that I can do that's not just specific knowledge to the signer.